What a day. Let's get some tunes. So what to work on today? Well, I've been thinking quite a bit about Rosby and our work on the index. I threw a little poll up on Twitter to discuss what are we going to do about the index. Should we continue battling to implement our own B plus tree? Should we use a pre-made library? For all intents and purposes, that will probably be better than what I'm going to write on the stream. Possibly. And should we continue learning how to build a B plus tree, or should we just continue learning how to build the server? So the results are pretty close, but edging on the side of continuing on with the index. So I think we are going to probably going to end up going down that road. Got to please the people, right? Maybe, but I'm just too darn tired today. I don't have a lot of brain space for that right now. It's been a long day, so I want to do something fun. I've been working on the adventure engine a little bit. And that's what I'm going to work on tonight, because that's what you got to do. Do things that bring you joy. Rosby brings me lots of joy, but it also requires a lot of work and a lot of learning. And that's fun, but you got to be in the right mood for it, in the right space for it. So the space is just not tonight. I also managed to break my mic stand today by accident. And just kind of a cheapy one I bought off Amazon that has some pretty non-standard fittings to it. So I'm gonna have to figure out how to deal with that. So I'm on the vertical side of it rather than the angled in line. So hopefully you can still hear me. Let's turn on some tunes. And let's get to work. So some of the things that I've done on Adventure Engine since the last stream, I think a fair bit. So I removed some dead code here, renamed some commands. So we didn't actually fully finish up that refactor by removing all of the dead code, so I just finished that part. Renamed the commands, took the ticks out of the names. See, so we actually we did end up on the side of having less code overall after this commit here, after that refactor. So that was a bit of a win. Then I added the ability to look at exits with the look command. So now you can look at an exit in order to get the exit's description. Added container objects. That was a pretty fun one. So this for the first time, used our new command structure to implement that. I had to also revisit the data structure we did for items, because originally it was just items, right? And items are things you could pick up and put down. Well, we wanted kind of other kinds of objects to interact with. So I made containers a kind of object and abstracted it out to the legendary game object. So if anybody's ever done kind of a game engine before, or read about them, or something like that, or maybe implemented your own, you might have implemented something called a game object. It's kind of a, I don't know, not the greatest pattern in object-oriented programs. I'm not sure that it's the best pattern here, but I tried a lot of different things. I messed around with using generalized gadgets, GADTs. I knew this was going to be a bad way, but I also tried making like a record, a property of the record, or field of the record, I should say. That's it. A type, some type that you can discriminate on, so you can tell different kinds of items, and you can make a container item or whatever. That not a great idea if you're ever going down that road. But I ended up with game object. Which isn't too bad. And the reason why I'm going down this route, instead of introducing like just a new record type called containers, is that we want to minimize the number of objects that we have to differentiate between in the world database, right? So if we have things you can interact with that are items, then you don't have to pull the world items database. If you have to pull containers, you pull the containers database. And then there have to be interactions between the two. And it's just the amount of, I think it's combinations, you could say, of the two would be significant enough that we were getting a little bit of repeated code doing this way. I also experimented with that as well, making separate, completely separate container types and adding containers to the world. So they ended up having like a lot of common fields, which you might see in Haskell code, and sometimes when dealing with records, like things that have names and descriptions. Pretty common thing that we're going to be implementing a fair bit. Do we need the extra duplication? Is it a premature abstraction? Not really. So when I created the game object type, I basically moved those common fields together. I'm sorry, I'm pointing at my screen, but you can't see my screen. I'll move my cursor down there. For this part here, that name and description. So we have one generic when you're rendering the room and looking at all the objects in the room, whether it's a container or an item, you'll get say the name or the name description or whatever it is. Then this object field contains the actual thing, which we can discriminate on, and that's the sum type. So that lets us tell game objects that are items away from game objects that are containers. And that's how we discriminate on those, is by that sum type and pull them apart. So I'm not like 100% on this. I'm like 90% it's going to be okay, because it does introduce complexity a little bit, not much, but it ends up nesting things, which I don't really like doing with records in Haskell if you can avoid it. There are ways around it, but they come with their own trade-offs. So nesting, try and keep things flat if you can. So that's kind of where I went with it. It's kind of clean in some ways, though. So I'll show you the next commit that I did. Review that one. So I added the look command so that you can look in a container. Right, to look into it. So not only exits, you can look at. You can look in container, which is pretty nice. All right. So this is where you get a bit of nesting annoyingness. All right, we get the container idea out of the game objects. That's fine, easy enough, easy peasy. But now we have to unwrap stuff. If it's an item, oh, that's the wrong thing. But that also lets us say, like, you can't look in an item. So, but you can look in a container. And that's how you get into it, right? We traverse, get all the items out of there, and blah, blah, blah. Added some utilities there for parsing. This might actually be up to date, so let me just fetch. Oh, I got a few more. Working real hard on it. Between jobs right now. I'm like 99% of the way to starting a new gig, so that'll be ending soon, but for now it's cool to just work on fun stuff for a bit. So to continue the adventure, yeah, I removed the unused language extensions. I added a take from, so I started adding the commands to interact with containers. So you can take items from it. And I'm liking this dynamic dispatch pattern here. Implementing take from, I just implemented it in one place and I add it to the list of initial commands that are available in the game state, to the default game state. I like that. It's handy. So I feel like that was the right path for that. I added a couple more parsing helpers. So split at word, peak word. If you've seen, if you've been following along with Rosby development, we did parsers pretty early on. These are very lightweight kind of parsers, but they got that same kind of pattern though. So that lets me pull in, handle the argument parsing a little bit more cleanly than we were before, with fewer bindings, which is nice. I think just using some of those helper functions here, just cleaning up in other places. What did I do? Current room function. Yeah, so I'm just, here is just kind of like adding more helper functions and breaking this code and the commands up, because it tends to look a fair bit imperative. So like there's a lot of, you know, try this and get this thing and then do this and then do that. And a lot of it's repeated in a bunch of places, like getting the current room. So I started cleaning those up. And that's kind of where I am right now with the project. And there's another refactor here, I think, that we could do and to compress the code down before we start on our journey to add more features. So I'll just give a quick demo of those new commands that were added, and we'll get into that. Adventure engine. Let's build it. I should have built it fast, but it's okay. So how's it going, chat? How you doing? How's it going, friend? Tell me a little bit about your day. How's your week? Okay, cool. Yeah, built. So let's just try that out. Dixie. Cool. So you can look. Cool. Front porch. We have pick up the purse. Walk the front door. We can look at the front door. That's new, right? Oh. Oh, did I mess that up? Looks like we might have a bug to fix. Let's walk the front door. Yeah, go with this door. Can we do that? No. Interesting. Okay. Got a bug. We got a Brawly bucket. That's our first container there. We can look in the Brawly bucket. And we get this message here. Inside the Brawly bucket, you see a Brawly. Right. We have take from. That basically works like this. Take Brawly from Brawly bucket. All right, now we're holding the Brawly in the purse. We look in the Brawly bucket again. Right, we see nothing in there. I don't know if I implemented put. Oh, I haven't put yet, so that'll be another verb to add later. We can still pick up the Brawley bucket. Pick up, one word. We're holding it now. We can't look in the Brawley bucket when it's in our inventory. Because look in, at least for now, only looks in the room. Walk through the door, drop the Brawley bucket. Drop the Brawley and drop the purse. We can examine the Brawley. So that's kind of the nice thing about doing the item restructuring the way I did it and breaking into game objects, is that examine didn't have to change all that much. Just had to change the types, a couple of types, but that's it. And then we get the functionality to examine it. Whereas if we had two different things like we do, we'd have to look in both. That would be just kind of annoying. So, kind of a win there. Yeah, that's what we got so far. We're getting there. It's getting game-like. Yeah, there's a couple more things I want to be able to do. Finish off more of the container verbs, so being able to put things in a container. Maybe maybe we want to start doing a little bit more object interaction, like with their weight and stuff like that. Make some items not pick upable. Things like that. And then I kind of want to experiment with doing like dynamic object interactions. So we said like commands. Items should be able to have commands. So if we pick up a shovel, it gives us a new dig command. But also combining items together to make new items, like crafting. Crafting system would be neat. Things like that. So we'll see. See where it goes. On the code side, that's where we're at right now, but there's probably some refactoring we could do here to tighten things up a little bit. Yeah, just kind of put in those helper functions, like current room. You know, we look up the current room a lot, so I made a help function for that. The exit for the current room. Things like that. So anything we're kind of really repeating commands, I'm trying to pull up in here. So my stream looks a little weird, sorry. Not sure if I'm actually showing up here anymore. Hang on. My stream preview looks a little odd. Hopefully it's still okay. You'll let me know in chat. Okay, yeah, it's fine. All right. Anyways, yeah. So, the reason why I want to do this though is because I want to start. I kind of want to start pulling together this. There's this pattern emerging in the code where we're doing all these lookups and there's a potential to fail on them. And we're doing all these lookups while we're updating, we're executing a command, right? And I think it ties really into this update notion of updating the world in our REPL. So when we do that handle and we handle the game state, this little function here, it's in here that we're doing all these things. And I kind of want to put the notion of the game state and failure together in one monad so that when we're implementing our commands, we can get rid of this constant maybe to write wrapping stuff that we're doing over and over and over again. We can turn those into throws where they're necessary and get rid of a lot of these constructors and stuff that are littering our code here. And hopefully it'll kind of compress things down and tighten things up a little bit. So yeah. What other one's kind of repeating itself a fair bit? Getting an object in a room, I think, is another one probably. Ooh, yeah, examine could be cleaned up. This could be cleaned up. So let's do that quickly. While we're here, let's just do a little compression run on this one here. So this one, we kind of just use pattern matching to do our parsing. For us, we have a helper function. I think that will fix this up a little bit. Basically, we have something that can peek at the first part. Let's just look at peek. So if the first word matches the head of the list, it returns the rest of the list, consuming that word that we peeked. All right, so if we peek at the my, that's all. We don't really use the my, we just use it for matching. We throw it away, really. So this function, I think, will be perfect for that. Okay, so we get case peek my of args. All right, we either get, in this case, we get just the rest of the args. We just call that args prime. And in the nothing case, simple. Right, we just get, we just look up in the rooms. So which one we look up in is basically what we care about. Is there a way we can compress this a little bit more? Oh, we're not quite done yet. Change that to args prime. I'm just gonna get this building in the background here while we're doing this. And file launch. Okay. Yeah, so we don't even use WWs anymore. Clean that up. Maybe we could use maybe. This might be a good use of it. Software data.map or import data.maybe. And maybe it's like this. I wonder, actually I was reviewing, I'm gonna just up my font size because I was kind of curious about that, if anybody has been trouble following along with the code because of this. But I actually don't know how to do that through running through this X server. Maybe that'll work for now. Okay, so that's a type of maybe. All right, we give it our b here, a function from a to b, and then maybe a. So our default value will be what we look up in the in the room by default. Our function from a to b will be, okay, well, or sorry, it'll be our peak. What if there's something else in data, but maybe we need, hang on. Kind of hoping for two functions. Data browse. That's just kind of the day it's been, folks. I thought maybe it would be a good one. Anyway, Well, it might be good enough for parsing our arguments. Alright, so what I'm thinking is that we just do like args prime could be equal to maybe then we can either do, in the case where we don't get a good peak, we don't get a peak that turns nothing, we do our key arg of args. But if we do we get the rest of the args. Then we do the key args of those. Right, and then we give peak here. Right. Since this A's is in the last position, we can go 0.3 on that one. Right. Get rid of some brackets here. That looks nice. And then we can get rid of this. What do we need to keep? Wouldn't even be args prime though. It would literally be object name. So yeah, let's do that. Get rid of that. Can dedent a little bit. Ooh, I love it. So the only last case is whether we're looking in the inventory or in the room. That might actually be the only reason why we want to keep peak around. So we can look in the global database. Oh, we're looking in the inventory or in the room. Yeah, okay. We could just peek again. We do still need that case. But in this case, we don't need the argument. We just need the fact. Okay, that's a little better. Let's see, we still got it. I think we need to restart this LSP here. Restart this workspace. Come on. There it is. what's my parser? Something weird. Oh, yeah, of course. Okay, thank you. Thank you, thank you, thank you. Alright. We can get rid of that as well. Okay, bam. Let's just commit that. Cleaning up the command argument parsing for examine. Cool, cool, cool. Moving on. Examining in the room. These are all helper functions. Those are okay. Looking good. Taking from. That's pretty new, so hopefully it's all right still. So we use a split out word here for from. Yeah, I feel like this is a pattern that repeats a little bit here. Object not in room. It's there. It's in examine in room. It's in examine, sort of. Although that might be duplication right there. We do it at looking container. We do it in pickup. So there's a few places. So I'm going to create a little helper function for that. Get item in current room. Get object in current room. To keep with our verbiage. Object. So this is kind of cool. I don't know if you've checked out the latest version of Haskell language server. But we're getting more editor commands here, richer ones. Which is kind of nice. Sometimes it can be pretty useful, actually. We can introduce a lambda, and it just kind of replaces that there. Yeah. We could look at the whole here. It gives us some more suggestions. And for some stuff, it actually can be pretty useful. So I like that. It's getting better. It's getting better fast. Probably like a year ago, everyone was complaining about IDEs and how terrible IDEs in Haskell are. And a lot of people showing up saying, like, I can't use Haskell, there's no good IDE. Well, we're working on it. And it's real nice. I like it. So good job. If you're watching this and you work on a Haskell language server, props, man. I will support your team and your efforts any way I can. If there's a Patreon, I will find out about it and I will start donating. Cool. Right, so get object in current room. We'll take a W, sure. We have to return either game object, gamer or game object. So we're just basically gonna hop down to, say, pick up. That's good. Let's copy paste to this. Or something like it. Maybe the next one. Maybe it's not the game object we want, it's the entity ID. Oh no. Yeah, let's get the object. Why not? Right. Yeah. And plop that in there. That's good. And the other part of it I want to get is just the look up the object itself from the world database. And that won't be underscoring. This one, we actually want it. Actually, we could just, yeah, we could just return that. So we got to pull the objects out. And we're going to want the object name, so we'll put a text parameter in there as well. Change that to W. And Bob's your uncle. Okay, nice helper function there. So let's see if we can replace that and if you use that to replace some few places or something. Yeah. Right, so in pickup, for example, we're moving the objects that we find into the player's inventory, which only need, what does it need? It needs the object name and the object ID. That's probably why we only have the object ID, huh? I'm just making sure the object ID is actually in the world. Yeah. So we're using some of the information in pickup. Maybe we did not look at this too hard. This one, walk to now. Maybe that wasn't a good candidate. I'm a little bit sleepy. Container. This follows our pattern here to the T. There we go. Oh, yeah, of course. Sorry. There we go. Booyah. Where else? We're just getting the object ID there. I think we're doing a little bit of repeated work here. Again, in examine. So you notice when we do peek here, let me just make sure I'm right about this. So we do peek here, again, a second time, just so that we know whether to examine the inventory and in the room. We look up the object ID to pass into examine an inventory. So we can give the object name and the object ID. Then, in examine in room, we're getting the current room. We're verifying that the object is in the room, even though we just looked it up over here. Oh, this one's in inventory, sorry. So we're also examining this not in the room. We're making sure that it's in the room. Okay, this is examine in room. This one is called down here, sorry. We get object ID and object name, yeah. And we call examine in inventory. And examine in inventory. Okay, that's fine. Examine in room, though. The object ID and name. Yeah, this one is kind of doing it twice. So let's get rid of that. And that. Let's just pass in that. And then in examine in room, we can use our function here to get the object. We get rid of this, this. Object then becomes in current room. Passing in the world and the object name. Don't use this anymore, so we can get rid of this. And we don't use objects anymore either. Cool. That shortens that up a little fair bit. Oh, I like that. Let's see, examine an inventory. This one's kind of weird too, because it's just doing double duty here, right? Like, we're looking up the object ID outside of that function, passing it into that function to just simply check that it exists in the world object. So this isn't even the right error to be returning. And yeah. Let's get rid of that again. Alright, so examine an inventory should examine the thing in the inventory by the object name. That's what it's for. So in that case, we need to get the item in our inventory. So let's get item in inventory. Let's just write that as a helper function. That seems like it's going to be pretty useful. In the object name. We'll get rid of this. Probably won't need it. Okay. No, not item, sorry, object. We're on the game object bandwagon now, friend. No getting away from it. Cool. It's gonna take a world and an object name. Home row, where are you? Yeah. Sorry, did LSP die on me again? LSP, whatever. HLS, whatever. So we get the object in inventory. Let's pull in our arguments. And just do as we do. The player inventory. And world. Probably need the objects database as well, just to validate. So we get the current room. Oh, we don't need the current room. What am I talking about? The object ID is in the inventory, so we do maybe to write on that. Object, not an inventory. And look up. Player inventory. And basically we return it. Well, it's probably validate that it's actually world database, just as a sanity check. Or something. Object ID in the objects. Presuming that's true. Actually, let's actually return that. That'll validate it for us. Yeah. I think that works. Get object in current room, get object in inventory, exit room, current room. Starting to build up a bit of a vocabulary of common ways we'd like to program our commands as we're working. So I kind of want to slowly start removing this sort of manual handling of arguments and looking up stuff and putting them in helper functions like that. Not all of them yet, unless we can. Okay, so then our container, we get the object in the current room. That's cool. So get examine an inventory looks a bit better. Examine room. Just gonna move them so they're in the same order as they appear in the source. That confused me a little bit. Let's see. They both kind of do the same thing. I wonder if we even need these to be two separate functions at this point. This way we can compress this just a little bit more. Try to ignore chat here. Yeah, well, we can get rid of that at least. Could we do something like maybe this? Except we do kind of actions based on that. Oops. Yeah. That's good enough for now. Let's not overdo it. Alright, take from. We can totally replace this here. Object in current room. Right. Container name. Okay. The one we want here. Oh, gotta take the world. Okay, the case split on it to get the item container. So we missed out on object ID for some reason. So we were pulling that out before. It's true, it's true. So if we actually really need that, let's see, object container. For updating world objects, including this the object ID. This is where we're taking from. Why did I update world objects? Sorry, I'm trying to remember was thinking here. Oh, right, yeah, because we modify the container, right? And we remove the item from it. So we need to update the database, the container in the database. Yeah, and replace it basically. Which is why we use insert there. So we do need the object ID of the container, not just the object itself. So why don't we do it like that? Or just get object ID. I don't know if I like this, but we're gonna go with it. Yeah, I don't know. Maybe get object in inventory and get object in current room are doing too much. Maybe that's the problem. It's nice if they return the game object. But maybe they should just return the object ID, the entity ID. Yeah, maybe it should. Because even that's kind of duplicating itself too. And composing functions is cheap. So we can get the object this way. Yeah, that's the one. Object. In this case, though, we don't have the object name for our object does not exist error. So invalid object. Maybe object does not exist shouldn't be text. I'm just gonna make one like we did before with a tick in it, so in case somebody else is using that error right now, I can fix that in a minute. But I'm gonna turn this back into that. The object ID. So that's really the problem. Okay. Splitting this up is making this a little bit more clean. We could actually make this a little bit smaller. Get rid of the do, it's kind of unnecessary. And to be honest, that doesn't really help us all that much either. So let's just put that in. Yeah. Yeah, it's a little better. Do it one more. There we go. That one still needs to be a do because, yeah, because getting the current room could technically fail. Because this function could fail. Oh, sorry. The current room could fail. The Space Wizard error if the game's in a weird, invalid state. That doesn't work. Okay, cool. That cleans that up a little bit. Let's see, what else can we do there? Let's handle that object does not exist thing. That one. Yeah, pickup, we use it. I kind of like it there in a way, although I don't know if it's the right error. Because this really should be, because we are looking up by the object ID. Right. Here. What do we got here? Right, right. This is an entity ID. object. That makes sense. We could probably... I wonder if there's a way we could like sequence those two functions together so that we can get the object without, because we don't really need the intermediate ID here. But with this pattern, anyways, that's something else. At least it cleans up this code here. The object does not exist thing though. We are looking up by object ID. Huh. Oh, this is a traverse. Yeah, this is a function for traverse. I wonder if we can traverse our get object function, not this local one. But we just have to pass in the world with it. Looks like we can. Maybe. Sometimes we've got build errors. Looks like my... I don't know, maybe I've sung praises of HLS a little too soon. No, it's still running. Okay. Okay, yeah. Yeah, examine an inventory, okay. Right, because this is an object ID again now. Same problem there. Yeah. Not liking this right now. I mean, just if I can compose them together, it would be a little bit nicer, so that when I do want to get the actual object ID from the name, that's cool. I can do that, but I can also compose them together to get the object from the world in one go. That's fine. Okay, so let's get back to where we were. Object notch does not exist. Okay, we use it in render to say that we're missing the object. We can't find it, and we still just show the object ID anyway. So let's shorten this part up. What? Okay. Looks like Haskell language server is just failing us right now. Or at least its integration with FlyCheck is kind of going a little weird. It would help if I fix things up a little bit, though. Because I'm doing dumb things. But, you know, sometimes as a human, you do. That's why we have great friends like GHC. That's right, GHC. You're my friend. I like you. Okay. Does not exist. Which one? I think they all have ticks on them now, except for the definition. Okay, so we can get rid of that one now. And replace that one with that. Cool. Alright, let's check our diff now. Yep. Good, good. Seeing a lot of red. I like that. Okay. That means it's kind of working. Right. Just... Okay, that's that. It's still less than 500 lines, not too bad. Okay. Let's see. Maybe we could do something with the container code to compress that. Well, I mean, that's one case. Yeah. We could do, oh yeah, we probably missed pickup here. All right, so object ID. This is get object in current room. Object name. Do a couple extra validations. We don't actually need the object itself, just the ID, so that's cool. And while we're here, let's just stack those. Those are fine. Okay, cool. Clean up pickup. Okay. We have an exit current room function. Yeah. Which use in walk 2. We could probably replace that here. In our look command. World. Tell me about the exit name then world. I should flip those around. Just get rid of that. That's good. Oh, I wonder if we could do that in render as well. So we have those traverse with get items, get exit. We can get same with you. If we had a get exit function with similar vein, we could also get rid of that one there. That's okay. It's only used really here, I think. We'll just stack those. I like it. I'm gonna commit it. And then I'm gonna just check in on chat and see how you're doing. Not a whole lot going on tonight, eh? That's okay. Just a chill stream then. Super chill. Well, we're down to 476 lines. We started a little bit higher, quite a bit higher than that. So, not too bad, not too bad. Do we get any errors? Okay. All right. So I think the next, we're almost ready for the next refactor here. I'm just checking the time to see if we can get started on it. Because one of the things, yeah, well, we can talk about it. Maybe we can get started on it. Let's see. So we started breaking things down into smaller helper functions where we wrote a lot of terms to look things up and get data out of here and move it out of there and yada, yada, yada. Right. We move them into these helper functions because we reuse those same patterns a lot, right? When you start seeing that happen, that's what you should do. Let it percolate a little bit first before you go off and start writing things and coming up with all the extractions. Haskell really has really good tools for working with abstractions and not getting lost in them, let's say. Even though it can sometimes feel that way, because if you are not very good at using that tool, or you don't fully understand it yet, it can seem a little bit overwhelming and confusing. And there's some debate about which ones are suitable for production code bases or not. And that's going to be a decision you're going to have to make between you and your team about which tools to use in the language, because Haskell's a big language. So let it percolate a little while is my advice. And if you find yourself repeating a lot of things, then put it in a function, because functions are our first level abstraction, our first defense against complexity. Put it in a function, abstract it out. That way. That's a pretty low level of abstraction. People understand that one. It's pretty simple and it's very easy to use. We have a lot of these functions that have kind of the same thing. Now, you can sort of see a new pattern arising. Right, they're all operating within either. Get object in inventory is in either. Get object in current room is within either. Same. So they're all, either's a monad. They're all operating the same monad. It's got a few other instances on it. So that's hint number one. Right, we're using either basically as our error catching mechanism. We're also passing in this world, and we're threading it through all of these functions too. That's another hint. Right, exit current room, get object in current room, get object in inventory. They all need access to world. All right, the only real parameters that change between them, these functions, are the ones in the middle. The entity ID, this one takes a text, or an item name, object name, an exit name, so on and so forth. So there's a hint that there's something going on there. There's a relationship between world and either. our result type. The other thing that has been kind of percolating for a while now, as some people might have pointed out, is that and then what I was mentioning earlier too, with handle and our REPL, it has the same kind of pattern as well. It's got this state, these state parameters that get threaded through every computation of handle, the text input line, and this monad, monad result, either game error world. So I'm thinking that these two types could be our application type and should be stacked together. Right? Our game state and our world state and error handling could be put together into a game application, like a game engine monad or something like that. And that would, if we do smash those things together, what would that get us? Right, because that's a little bit of extra abstraction. It's not a little bit more difficult to work with than just function application and extracting functions out into smaller functions, or terms out into smaller functions. So if we go down this route, I expect to see, we should be able to get rid of these constructors with more meaningful, and replace them with more meaningful things like row, error, whatever it is in the library. I think it's like throw something, whatever. Right. So we should get rid of those constructors. And threading the world through in all of our functions. Right, now our command handlers as well could also be compressed down to operate within just our monad. They would just operate on the text input. So that's kind of what I'm thinking we could try out. Not sure. I'm a little hesitant about it because it is a little bit of extra complexity, and like threading the world off the world parameter through, and it's getting painful, but it's not the worst. Right. But it's one less thing we'd also need to remember to pass through everywhere and stuff. It'd be available in all the different places, so why don't we give it a shot and see how it goes, and if we like it, if it's actually giving us what we want, which is, if this is going to be a good refactor and a good abstraction, we're going to be able to get rid of a lot of these constructors and replace them with our more thing. I think monad error would be a simple one, and even if we don't want to stack the two monads together, and we just want to change either to monad error, that would be a good change. Just so we can get rid of the constructors. But what else? We should also see, yeah, that world parameter kind of go away from a lot of the functions, and we can explicitly ask for it when we need it by updating the game state. We might even be able to see the REPL code kind of get kicked down a notch, because we could be able to put our render part and sort of hide that plumbing inside our monad update loop, and kind of hide the plumbing for all this error handling stuff, which is kind of exposed right now. All right, if you look at REPL in our loop, right, all the plumbing of our game loop is really exposed. We handle it. We gotta get an error. We get a new world. Then we got a render world, which is gonna have a render error. We should at least be able to get rid of this level of nesting. We could get rid of that. Might even just be able to get rid of it altogether, maybe. Because input. I don't want to get ahead of ourselves, but input T here is defined by Haskell line, and I believe that's a monad transformer as well, which we should be able to put into our stack at the very bottom. And then we could really tighten up this code and hide all this gross plumbing here. And it's, when we say hide, we're just kind of shifting complexity around a little bit. But that might have some knock-on effects down the road. Okay. So what is it? What would that look like? And how do we insert that in here? Let's start at our types and definitions. That's our world, our kind of demo world. Game state. All right, why not do it right here? Okay. Right, so we've done monad transformers in Rosby, but we haven't really done them on the adventure game. So I'll kind of explain this. This pattern isn't really explained in mini patterns because it's not a very mini pattern. I assume if you've been watching the stream so far on this adventure game engine that you know what the mini patterns are, the Haskell mini patterns. That's Kawaiianic. Their blog post on it, and I've been kind of starting this adventure game engine as a way to demo some of those, but I've just been having so much fun working on it that it's been growing. So I feel like this is kind of the point where monad transformers might start to become a little bit useful. We're starting to have enough code where they kind of make sense. Maybe. We're gonna see. Alright, so we're going to start with our new type. Already in engine. Do we have a type called game engine already? Okay. Call it game engine. For lack of a better term. And that's going to basically be a record with a single field. Alright, and then our... Oh, that's going to go in there. We're going to put a couple of type parameters on there. M, is the, you'll see this a lot, it's colloquially the monad, or what's the other word for that? Conventionally known as the monad type, if you name your type parameter M. A, our result type. So what are we going to put in here? We're going to put state. What is our state? I'm wondering if we should start putting world in game state here as well. Like mess world in here. Like that. Right, game state. That's not enough. We also want error T, or game error. Something like that. I haven't imported everything yet, so this should be throwing like hella errors. Alright, so why don't we go ahead and do that. And control.monad.error. And might need to restart. And actually need to do a build to get those dependencies pulled in and compiled. What's the Shah? Oh, right. Sorry. My bad. And that'll probably be... Nope, nope, nope. I'm messing up the stack here. State T. Yeah, blah. And then data. Oops, 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 oops. What did I do? Bork, bork, bork. Oops, deprecated. Oh, cool. Deprecation error. Nice. Oh, look at that. It even crosses it out. Huh. The hidden member of hidden package transformers. That's new. I haven't seen that yet, so let's go look that up quickly. Until 2. Yeah. Okay, so yeah, that's what we're used to. How come... Doesn't mention being deprecated or anything about that. Yeah, E the exception type and M the inner monad. That's going to be our state monad. That should be... That's weird, okay. Huh. Okay. Odd. This gives me... a deprecation error? Really? Anyway. Okay. Dun, 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 dun. Oh, it's not error T, is it? It's except T. That's why. Gah. Gah. Gah, 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 gah. There we go. Aha. That's what I want. So let's build. Make sure that works. Yeah, we're going to get some errors in our default game stakes. We got a new constructor for that. But fortunately, I think it's only in one area. Hopefully that's it. Yes. Yes, yes, yes. All right. So we got a game engine monad. Don't we use the maybe function? Why does I think it's not? Or did I take it out? I guess I did. Anyway. Anyways. Cool. So this lets kind of centralize a lot of the like behaviors of our game engine. You know, maintaining the state, as well as being able to throw exceptions. If we want to do any kind of logging or anything like that for maybe capturing game logs or sessions, we can do that as well. But I think this will be enough. Also, oh yeah, we might also stack this on top of input T at the bottom. Or we can even wrap this around input T and give input T as our monad for the game engine. And run it that way, or we could also create a little test monad so we can, if we wanted to start writing tests for this, unit tests for that, we could just write like a simple one that captures the game input and then test for things render properly, or the command updates the state in the proper way, that kind of thing. We're running low on time, so maybe we'll do that next time. I will add this back in. Added the game engine monad. Well, let's pull it together. Game state, and error handling into single interface. Okay, cool. That's what I got for tonight, friends. Haskell always heals, man. Makes me feel better. It's been a rough day, but I hope you've had a good one. And I hope we'll see you again next week. Same bad time, same bad channel. I might do some more bonus streams while I still have a lot of a lot of free time. And we'll see you around. I'll try and make sure that we do some Rosby coming up though, because I've been thinking quite a lot about that. And there might be some cool stuff to work on that for that. So yeah. Thanks for joining me. This has been fun showing some refactoring stuff. I think that's pretty great. You don't get to see a lot of refactoring a whole lot in Haskell, so there you go. As always, may your monads be free, may your types always check, and see you on the flip side. If anybody says that anymore, I don't know.